Hi, ladies and gentlemen. The first thing we are going to be learning about in Unit 4 is understanding rates. So we're on page 3 of our notes, and we are looking at notes 4.1, understanding rates. Just to give you a heads up, when I start going over number 1, you're going to see this headline here that says notes 4.1 will be a different set of notes, but don't worry about it. Just go ahead and watch the video and see what is going on.
Let's look at question number 1. If you leave home and walk in a given direction at a steady pace, your distance, which is measured in d feet, from home is directly proportional to the time, which is measured in x minutes, that you walk. You can use a table and a graph to represent this proportional relationship. Proportional relationships is not something new that you have learned. You learned it in 7th grade last year. So let's fill in our information right here. If this is a proportional relationship and it's going up, in 1 minute the person walked 250 feet, in 2 minutes they walked 500 feet. So it's clear that they're walking an additional 250 feet every hour, or excuse me, every minute. So this should be 750, right? And then this should be 1,000, and then this should be 1,250, okay? So then, what is the constant of proportionality? Well, you guys do this all the time. You figure out that the person is walking 250 feet every minute. So 250 feet in 1 minute. So the constant of proportionality is 250 feet per minute. Okay, now we could have done it using this data right here. We could have taken 750 and divided that by 3, and we still would have gotten 250 feet per minute. All right, so now I need to graph this information that's given in the chart. First of all, I need to identify what is my independent variable and what is my dependent variable. So go ahead and think about which one is which, and then come back to me when you're ready to go. Hopefully you determine that the time in minutes is your independent variable and that the distance is your dependent variable. So we're going to call this graph right here distance versus time, okay? And then down here, we're going to label this right here our time. And our time is being measured in minutes, okay? And then over here, we're going to label this piece right here our distance, and the distance is measured in feet, okay? And so what I'm going to do now is I'm going to graph out my information. So time in minutes, I can just go up by a minute for each interval, okay? And then I think I'm going to go by 250 for my feet. So every block will represent 250 feet. So I will put 250 here, 500, 750. It's really up to you how you guys want to label it, as long as you include all of your numbers. So I'm going to say that this is 1,500 right here, and that this is 2,000, so on and so forth. And I know that after 0 minutes, I've gone 0 feet. Okay, after 1 minute, I've gone 250 feet, 2 minutes is 500 feet, so on and so forth. And you guys have learned that the equation for this line, remember this y equals kx right here, and in this example, our constant of proportionality is 250, so you would say y equals 250x. Now notice there's nothing added on here, it's plus 0. We're going to be talking about this in the future. But this right here, this y-intercept is going to be part of our equation here. We're going to add that on into our equation in the next couple of days. So question D says, using rise over run, find the slope of the line. Well, the rise is how much it went up by, the run is how much it went over by. So for example, if I wanted to start here and end here, I would figure out how much the rise is. You need to make a triangle in order for this to work for you, a right triangle. So the rise, it went up by 1,000 feet. So my rise is 1,000 feet. Okay, and then the run, it went over by 4 minutes. So now I can just divide the information and I get 250 feet per minute. And then the nice thing about this is no matter what I use, I'll always get the same constant of proportionality because it is the constant of proportionality. It's constant, it doesn't change. I could have started here and I can end at a different spot or the same spot, it really doesn't matter. And then my rise right here is 500, right, feet. My run is 2 minutes. So my answer here is still going to give me 250 feet per minute. So just so that you guys know, slope and constant of proportionality are very similar, except the constant of proportionality means you're always starting at 0. Your y-intercept is 0. With slope, it means your y-intercept could be anything you want it to be, but it's always going to be the rise over the run. How much it went up by, how much it went over by.
I want you to skip question number 2 for right now, and we will talk about that as a class next time I see you. Right, on page 4, we're looking at question number 3. Question number 3 says the graphs give information about a penguin's number of heartbeats measured as B over time t minutes during normal resting and just before diving. When is the penguin's heart rate greater, during normal resting or just before diving?
So to figure out the heart rate, we just have to figure out how many beats per minute the penguin's heart is beating at. So right here we know that it took, just like we always do, 150 beats in 2 minutes, but it's really because the rise was 150 beats and the run was 2 minutes. So when you divide that information out, you get 75 beats per minute. Okay. And then over here, I'm going to do the same thing. You could divide 400 by 2 because it's a proportional relationship. It starts at 0. But I want you guys to get used to now doing rise over run because it won't always start at 0. So I'm going to do the rise over the run. And here the rise is 400 beats. And it took 2 minutes. So the answer is 200 beats per minute. Okay. And the question is asking, is the heart rate higher at normal resting or just before diving? So hopefully you understand that the heart rate is higher before diving. So you would say the penguin's heart rate is higher just before diving.
All right, let's take a look at question number 4. It says the graphs give information about the distance d miles traveled over time t hours by cars and trucks on a California highway. Which speed is lower? So again, all I'm going to do is I'm going to figure out what's the rise of this problem and what's the run of this problem, just like we've done in our previous examples. So our rise for this problem would be drawn in like this. So I'm going to do my triangle, right? So here's my rise. Now, a lot of people look at this and say it's a rise of 1, 2, but they're not looking at these numbers carefully. It is not a rise of 2. It's actually a rise of 100 because it went from 0 to 100, right? And then the run right here is that it went over to 1.5, right? So my run is 1.5. So remember, we're going to say that it's rise over run, which is 100 over 1.5. Now let's figure out what 100 into 1.5 is. So I'm going to figure out 1.5 goes into 100 how many times? Well, I have to move this over once, so I have to move this over once. So it really turns into 1,000 divided by 15. So let's figure this out. 1,000 divided by 15. Well, 15 doesn't go into 1, it doesn't go into 10, but it does go into 100, and it goes into 100 6 times. 6 times 15 is 90, okay? So then if I do my subtraction, I get 10, okay? Because 100 minus 90 is 10. Bring down the 0, 15 goes into 100 6 times, and you would keep going with it. So it's 6.6 repeating, okay? So I'm going to say it's about 67. Now you have to understand that you have to label the units for this right here. So this is 100 miles in 1.5 hours, and I know that just based on what's written right here. So it's 67 miles per hour. You have to have a unit for your slope and for your rate, and your unit has to be in something per something. All right. So now let's go ahead and do the same thing for the speed for the trucks, okay? This was the speed for the cars. So the speed for the trucks, I can figure out that the rise is 100 and the run, it went over 2. So it's 100 miles in 2 hours. So that is an easy division. I end up getting 50 miles per hour. Okay, so then we can answer the question, which speed is lower? The speed of the truck is lower. And then we're done. Make sure to let me know if you have any questions about anything that we've watched. I hope you have a great day.